Welcome back, Math 005. This lesson is on 3.5, which is all about slope. The objectives here, we're looking at rate and slope. Rate we looked at in 3.4, and now we're going to tie that into just looking at some graphs, less application, but more just graphical approaches. We're going to talk a little bit more about horizontal vertical lines and the slope of those, and then we are going to look at a couple application problems. So the first example here. We want to state whether the rate is positive, negative, or zero. So without seeing a graph, what we want to do is just read the statement and figure out, okay, does this describe something of a graph? Meaning, if we have an x and a y axis, would this graph here be going up? Would it be going down? Or would the rate here be staying the same, meaning it's a straight line? So that's what we want to think here. If we were to graph this, what would it look like? So the first example here is, okay, it's asking us the rate at which a pond's water level changes during a drought. So we need to think, okay, is the water level going to increase? Is it going to decrease? Or is it going to stay the same? So this also takes in a little bit of common sense because you have to think about what would it do in this given situation. And if it's a drought, mean it's not raining, so it's definitely not going to be increasing. And we all know water evaporates, so therefore the water level is going to be a negative rate. So if we were to actually pull the values and graph those, we would see that it would be a line going in the negative direction. So slope, what is slope? And what slope is, it's going to be the change in the y values divided by the change in the x. So we want to say the change in the y divided by the change in the x values. And this is between 2 points, just like we looked at in the last section. When you have 2 points on a graph, if you find the difference in their y divided by the difference in the x, that's going to be the slope. The formula here is going to be m equals y2 minus y1 divided by x2 minus x1. This should look very familiar from what we just did in 3.4 when we did, remember we said you take the end minus the start? It's the same idea here. You're taking the second y value and subtracting the first. This formula, you should make sure you know this formula. You need to know it for this class, but also and when you go on to your next classes, you must know this formula. So make sure you take the time to memorize it and learn it because you have to know this. We're just going to draw a little picture of what slope really is. So what we want to do is whenever you have 2 points on a graph, and this is just going to lay out nicely some of the things we've looked at before, and I'm just going to plot any 2 points here, it doesn't matter which ones. And then I'm going to connect these two with a line. So I'm going to get my ruler back up here just so I can make a nice straight line to make it look a little bit better for us. Looks something like right in there. We're going to go with that. And then we want to connect those. All right, so now we have that line right there. So what we'd want to do is we would want to find the change in the y values. So meaning the change in the y values, we always want to do the y first. So it's going to be the difference from that y value down to that y value. And then you'd look at the difference in the x value. So going from here over to here. And since when we started here, to address the y first, we went down. We know that would be a negative value. And so here it went down 1, 2, 3, 4, 5. So it went down 5 and it went to the right 1, 2, 3, 4. So therefore the slope of this line would be negative 5 over 4 because it's going down 5 places over 4. Again, this would be the change in the y divided by the change in the x. So a lot of times we use this little triangle, the delta, that represents change. Example 2, find the slope of the line containing these points. Now drawing pictures always works out nicely. However, sometimes you might have numbers that are really large and you're not going to be able to plot them on a grid. Or maybe you have decimals of fractions and you can't just count the blocks nicely and easily. So that's why we have to use the formula that we just previously looked at. So what we want to do is we want to give each of these points a variable. So the first point is going to be x1 and y1. The second point is going to be x2 and y2. Oops, let's get this ruler out of here so it doesn't goof me up. Let's go back. So we have x2 and y2. There we go. So again, we want to use the formula, so we're going to take m. Slope, I'm sorry, I didn't mention this, but slope is always noted by m. That's going to be an m. You can see if you can Google why is slope m. There's a specific reason why they chose the variable of, or the letter m there. So see if you can find that out. And I know what it is, but I'll let you guys find it. So we want to do m equals y2 minus y1. You can see the y2 value is -1 minus y1, which is 5. And we're dividing it by our x2, which is 4, minus, and this is where we want to be very careful, it's x2 minus x1. So it's 4 minus a -4. And then you want to just subtract across the numerator and denominator. -1 minus 5 is a -6, divided by 4 minus a -4, which would be a +8. Now we always want to reduce fractions as much as possible, so that'd be a -3/4. So you would know that if we were to plot those two lines, we'd have a line going down, just like in the diagram I drew above. So now this next one I'm looking at, what is the slope of the line y equals 3? So let's go back and plot or graph that line. We know y equals 3 means it only crosses the y-axis at 3. So if I were to graph this line here, now if I were to take this line and pick 2 points on this line, and it doesn't matter which 2 points I pick. Let's go with the one that falls right on the y-axis, which would be the point that would be 0, 3. And let's say I choose the point, we'll go over here, 4, 3. Now what I want you to do, I want you to pause the video, and using these 2 points here, or whatever 2 points that you chose off the line, then go back to the slope formula and substitute those points in and calculate the slope. I want you to pause it and try it for yourself and then restart the video. Okay, you can see that I let my first point be x1 and y1. That's a 1 there. My second point, x2, y2. You'll notice I'll write this notation out with my points every single time that I do this, just so I remember what is going where. So we have m equals, sorry if you hear that, my dog's running around like crazy, y2, which is 3, minus y1, which is 3, and we're dividing it by 4 minus 0. And you'll see our numerator is 3 minus 3, which gives us 0. 4 minus 0 is 4. We get an answer of 0. So the slope of this line is 0. And you'll notice that they have the same y value. Anytime you have the same y value like that, that tells you your slope is going to be 0. So now what we're going to do is the same idea, but we want to find the slope of the line that's x equals -2. So now what I want you to do is I want you to follow this whole process we did, but I want you to do the same thing for x equals -2. So start by graphing the line, choosing 2 points, use the slope formula, and see if you can find it. Again, I want you to pause the video, try it on your own, and then restart it. Okay. First thing we do is graph the line x equals -2, which you can see this pink line I graphed right here. We know since there's no y, it doesn't cross the y-axis. Then I picked 2 points. I chose these 2. It doesn't matter which 2 points you choose on this line. You'll notice that when you choose your 2 points, they have the same x value. Let one of your points be x1, y1, the other point be x2, y2. It wouldn't matter which point you let be the x1 and y1, x2 and y2, as long as you kept those subscripts of 1 and the subscripts of 2 together within the same point. Then we substitute in the slope formula to get the numbers I use, 2 minus 1 over -2 minus a -2. Now, depending on which points you used, you might not have a 1 here. However, no matter what points you have, you'll have a 0 in the denominator. Now, this is where you have to be very careful, because when we want to simplify or evaluate this, 1 divided by 0, we do not get 0 here or 1. This is undefined. This is always going to give us undefined because we can never have 0 in a denominator. So with this idea right here, or with these 2 ideas right here, I should say, this is what we're going to talk about with the next example. Looking back, vertical lines like the pink one here, they have the same x value or the same x coordinate, Horizontal lines will have the same y. So if you just see a point and you recognize that, you can go. So it says, what can we generalize about the slopes of vertical and horizontal lines? So we can say that vertical lines, so that would be a line that goes up and down, has a slope that is undefined. This is the word you have to use for that, undefined. Whereas a horizontal line has a slope that is 0. So horizontal line, the slope is 0. Vertical lines, the slope is all undefined. And that remains true for all vertical and horizontal lines. Keep in mind, vertical lines relate to what the slopes are. If you forget, graph it, pick 2 points, and calculate it. All right, the last thing we have here, let's see if we can get rid of this ruler here. Boom, okay. So the last thing we have is applications. What is the grade? So what we're talking about with grade is this is going to be the steepness of something. And a lot of times in real life, we talk about grade. It's like going to be the steepness of a road. So it's a measure of a lines or a measure of, we'll go with the, what was it, measure of. So what we're going to write for this one is we're just going to say it's going to be the measure of the steepness. Now when we answer with the grade, so we're going to say the measure of the steepness. Oftentimes, this is expressed as a percent. Expressed as a percent. Now, like I was saying, a lot of times we see this in real life as the road grade. You might be driving and there's a big hill, either going up or down, and it'll give you the percentage of the inclination of the road. And that's where this comes from. That's the grade here. And the grade, again, just like we talked about in the previous section, is always going to be the change in the y over the change in the x. So we want to think of this, and I'm going to kind of come down here because I'm running out of space. So we want to think of it as the change in the vertical over the change in the horizontal. And that's going to be changes vertical up and down, which would be the y, horizontal would be the x. So this example 3 here. Among the steepest skiable terrain in North America, the head wall on Mount Washington in New Hampshire drops 720 feet over a horizontal distance of 900 feet. Find the grade of head wall. Again, we want to do the change in the vertical divided by the change in the horizontal. And it tells us it drops 720 feet divided by a horizontal distance of 900 feet. So we set up the problem like that. Now, we're going to say it's usually expressed as a percent. So what we want to do here is divide these two numbers. So we get 720, and this will give us an answer of 0.8. Now, remember back to Unit 2, to convert this to a percent, you'd move the decimal over 2 places, or we can think of this as multiplying by 100%, which would give us a grade of 80%. And if you're familiar with any kind of skiing or anything, that is a very, very steep hill that you would be skiing down. Okay, in this last example we're looking at, example 4, we want to find the rate of change of a country's defense outlays using the graph. First thing we notice when we look at the graph that this is it going to be a negative, or I'm sorry, is it going to be an increase or a decrease, or a negative or a positive? Since this graph goes down, going from left to right, it's going down, we know that it's going to be a decrease here. Let's get rid of that crooked line. We know it's going to be a decrease or a negative value. Now, this goes back to using the slope formula like we did in this section, or going back to 3.4. You can pick any 2 points on that line and use the slope formula. So what I want you to do is choose whichever 2 points you want. You can use this point, this point, this point, this point, this one, or this one. It doesn't matter which one. So pick one of these points, I'm sorry, 2 of these points, and use the slope formula. So choose 2 points, and then we're going to use the slope formula in case you haven't remembered it yet. M equals y2 minus y1 over x2 minus x1. So go ahead and do that. Pick any 2 points. Okay, I'm just going to walk through this whole thing with you. If you chose two different points than me, that is entirely okay. So let's see, I'm going to start by choosing this one up here on the y-axis. So this point right here would be the point. Now you want to keep in mind here that this point here, it's not just 1, 2, 3, 4, it's 2001. So the x value is 2001, the y value is 310. So that's one of my points. And then I'm going to use the very last one here. So my x value is 2006. My y value kind of falls in the middle, and it looks like it'd be 285. If you didn't want to use one that fell in the middle, that's okay too. So now we're going to substitute these values in. So my y2, so I have x1, y1, x2, y2. So we have 285 minus 310 divided by x2, which is 2006, minus x1, which is 2001. Again, it doesn't matter which points you choose, your answer should still be the same as mine. So we do 285 minus 310, and we're getting an answer of negative 25, which is good because remember we said the line's going down, so it needs to be decreased. And then 2006 minus 2001, and we get an answer of 5. Negative 25 divided by 5 is going to give us a negative 5. Now we have to answer it in terms of what the graph is giving us. So it's going to be negative $5 billion per year. Negative $5 billion per year, or it decreases $5 billion per year. Good luck on your homework. Let me know if you have any questions.